Good afternoon, everyone. This is my movie of the space mission of the Parker-Solar probe. This scientific mission to boldly go where no thing has ever gone before and to unlock the mysteries of the sun's corona and solar wind. This mission is named after Dr. Eugene Parker. Dr. Parker was a solar physicist who developed the theory of the solar wind. He predicted the spiral shape of the solar magnetic field in the solar system. The Solar Parker probe is the first NASA mission to be named for a living person. These solar panels are the life source of the probe, used to sustain it throughout the mission. These solar cells were designed to work at a high irradiance levels. The problem wasn't getting enough energy, but keeping them cool. When at the sun's perihelion, the solar panels would tuck themselves behind the probe's heat shield to create adequate protection from being that close to the sun. A spacecraft that uses breakthrough technology and autonomy to endure heat and radiation like no other mission. Here we see a probe as it was being prepared for launch. During launch, the probe was protected by a slender fairing housed atop the rocket for launch. The Parker-Solar probe was launched on August 12, 2018. It used the United Launch Alliance Delta IV heavy rocket to propel it from Cape Canaveral Air Force Station in Florida. The Space Control Team at Johns Hopkins Applied Physics Laboratory, or APL, in Maryland are the spacecraft control team. They initiated a maneuver early in the launch that was critical to the probe's trajectory towards the sun. Here we see an artist's rendition of the probe around Earth. This graph shows the Parker-Solar probe perform the first significant celestial maneuver to orbit Venus, allowing Venus's gravity, small by celestial standards, to twist its path and change its speed. This accomplishes moving the probe to orbit the sun closer more times than using Jupiter's orbit to propel itself around the sun. Here we see an artist's rendition of the probe around Venus. On July 11, 2020, the spacecraft was conducting its third Venus's flyby. The team switched on the spacecraft's wide field imager for the Parker-Solar probe instrument, called WISPER, to take a peek at Venus. We spoke about the orbits that the Parker-Solar probe takes around the sun and Venus. This graph shows various points when the probe was by Venus. This picture shows when the probe was at the sun's perihelion, the point at which it is closest to the sun. This solar wind is the continuous outflow of particles and magnetic field from the sun. Both speed out, filling up airspace and affecting the space weather around the solar system. These strange lines are called switchbacks and are magnetic field lines that whip and flip and turn opposite ways in a matter of seconds. This image from the Parker-Solar probe's WISPER, Wide Field Imager for Solar Probe, instrument shows a coronal streamer. Coronal streamers are structures of the solar material within the sun's atmosphere, the corona, that usually overlie regions of increased solar activity. Parker Solar Probe was about 16.9 million miles from the sun's surface when this image was taken. The bright spot near the center of the image is Mercury. The Parker Solar Probe is the first spacecraft to fly into the low solar corona. It will assess the structure and dynamics from the sun's coronal plasma and magnetic field. The energy flow that heats the solar corona and impels the solar wind, and the mechanisms that accelerate energetic particles. A unique solar view that will orbit 4 million miles from our star's surface to directly study the formation of the solar wind, which is why it is such an important mission. This animated sequence of images from the Parker Solar Probe's WHISPER instrument shows a coronal streamer, bright loop-like structures that developed over active regions of the sun. The probe observed this when it was near its perihelion on January 28, 2020. The Parker Solar Probe was making its closest path to the sun on June 7, 2020, when its wide field imager for the solar probe, WHISPER, captured the planets Mercury, Venus, Mars, Earth, Jupiter, and Saturn in its field view. This is an image of the Parker Solar Probe mission team at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, shortly before the spacecraft was launched in 2018. Without their tireless effort and hard work, none of this would have been possible. A mission of imagination to reality, and a mission of discovery. This has been my presentation of the mission Parker Solar Probe, a mission to touch the sun.